Hello friends, my name is Pooja Arora, Assistant Professor at Bani Group of Colleges. On behalf of GuruRKPA.com, I am giving you video lectures on the subject of discrete maths, and we are discussing the topic relations. In the last video lecture, I have already discussed what is relation and some type of relation. The first type of relation was reflexive relation and the second one was symmetric relation. We have already seen that what is reflexive and what is symmetric, and today we are going to discuss the third type of relation, that is called transitive relation. Friends, we have already discussed that what is relation. Relation is a association between two set or maybe the same set, okay, and to be a particular type of relation, the set of relation must have to satisfy a particular condition. For example, if I am talking about reflexive relation, the condition was कि for all elements they must be belong to itself. So this is a condition for reflexive relation. And if we talk about symmetric relation, then the condition is if a element A belongs to a element B, then in the relationship set the element B must be belongs to elements A with the same condition given in the relation. So these two are the symmetric and reflexive relation conditions. And what we are going to study today, that is called transitive relation. In this type of relation, transitive relation, the condition is if AB belongs to R and BC belongs to R, then AC must be belongs to R. So I will repeat the condition. What is the condition of transitive relation? That if two elements A and B are in the set of relationship set, A relate to B and B relate to C with the same condition given in the relation question belongs to R, then you have to check that AC must be belongs to R. So this condition satisfy the transitive relation. Okay, let's take an example of transitive relation itself. Okay, if I am giving you a relation R described as on a set of for all A, B, C belongs to capital A. So there is a set A in which there are three elements, and I am giving you a relation R such that A is less than equal to B. This is the condition for all AB belongs to R. Belongs to R. So this is the condition for the relation, that A must be less than or equal to B. So if I try to make the relationship set, what is well? For example, I have a set 1, 2, 3. Okay, so what will be the set? 1 is less than 2 and 1 is less than 3, 2 is less than 3, 1 is equal to 1, 2 is equal to 2 and 3 is equal to 3. Okay, so this will be my set of relation. So in this set, let's check that which type of relation is it. The first type is reflexive relation. Let's check, is it a reflexive relation or not. The reflexive relation condition says that for all A belongs to capital A, A must be belongs to R. That means every element is belongs to itself. So if first element is 1, in my relationship set 1, 1 belongs to R, that means 1 relate to itself, 2 relate to itself, 2, 2 belongs to R and 3, 3 belongs to R. All three elements are relating to itself. So this relation is a reflexive relation. Okay, and the second was symmetric relation. Is it symmetric or not? Okay, symmetric condition says that if AB belongs to R, then BA must be belongs to R. Okay, so in this example we have seen that 1, 2 belongs to R, this is A and this is B for me. So if it is a symmetric relation, then 2A must be belongs to this set, but there is no such element. 1, 3 belongs to R, but 3, 1 is not belongs to R. We have seen some of the examples that this relation is not symmetric. Okay, and the third one says transitive relation is AB belongs to R and BC belongs to R, then you have to check only AC belongs to R or not. So this is my first pair. So AB, this is A and this is B for me. 1, 2 belongs to R and this is A, this is B. And now I'm trying to find out a pair BC in this set. So B is 2, so I get first this pair BC. AB belongs to R, BC belongs to R, then I have to check that AC must be belongs to R. So I have to check that 1, 3 is belongs to this set or not. So we find a pair 1, 3. So we can say that this satisfies the condition. Now I will move to my next pair and make this one is A, this one is B. And now what is BC for me? The pair which start with 3. So only this one is starting from 3. So this is BC for me. So what is AC? 1, 3. I am getting the same pair again. So here also the condition satisfy of transitive relation. So we are moving to the next pair. Next pair is 2, 3. Here this is A and this is B for me. And again B is 3. So I am moving to the BC. So 2, 3 must be belongs to R and it is giving me the same pair. It is relating to the relation. Same way you can find another one, 1, 1, 1, 2, 1, 2 is there. So this relation is a transitive relation. What you have to check only if AB belongs to R and BC belongs to R, then you have to check AC belongs to R or not. If any one of this condition dissatisfied, that means if AB belongs to R but BC is not belonging to R, then we are not going to check AC belongs to R or not. We are simply saying it a transitive relation. So and if we explain the condition of relation theoretically, then we must know that the condition was A is less than B. Element is less than to another element. Okay, so if my first element is less than to second element and second element is less than to third element, then the first element must be less than to the third element. So this is called my transitive relation. Now we have discussed all three type of relation. The first one was reflexive, second one was symmetric, and the third one was transitive. And if any relationship set satisfies all three conditions, that means if a relation is reflexive, symmetric and transitive, then that type of relation is called equivalence relation. Now the question is, what is equivalence relation? Then the answer is, if a relation is reflexive, symmetric and transitive, then that type of relation is called equivalence relation. So if a set of relation is given to you and you have to find out that is it an equivalence relation or not, then you have to check all three conditions. The first condition of reflexive relation, second condition of symmetric relation, and the third condition of transitive relation. If all three conditions satisfy, then you will say that this is an equivalence relation. Okay, so we have a sum of examples here, the set of relation, and we are going to check one by one that which type of relation is this. Okay, let's start with the first one example. These all relations are described on a set A in which three elements are there, A, B, C. Okay, so we are going to check each of the relation. I am moving to the first relation R1, and in the set of R1 I am going to check all three conditions. The first condition is reflexive relation or not. Okay, and we know the condition of reflexive relation, that A must be belongs to R, means all the element must be belong to itself. So to check this relation is reflexive or not, we are checking A belongs to itself, AA must be there, BB must be there, and CC must be there. Okay, so in this relation we found AA, we found BB, and we found CC. So we are saying that this relation is reflexive relation. And now moving to the second one, symmetric relation. Symmetric relation conditions is, if AB belongs to R, BA must be belongs to R. So here AB belongs to R. Now I am searching for BA. Is it belongs to R? Oh, I didn't found it. BA belongs to R. So BA is not belongs to R. That means this is not symmetric. Reflexive, symmetric and transitive. It is reflexive but it is not symmetric. Okay. And what about transitivity? If for transitivity I am moving to AB belongs to R, BC belongs to R, then AC must be belongs to R, but I didn't get the pair AC, so this is also not the transitive relation. So this relation is of only reflexive, it is not symmetric and not transitive. Okay, let's move to the another example. This is my second set of relation R2. In this we have to check all three conditions: reflexive, symmetric and transitive. Okay, the reflexive condition, AA belongs to R, BB belongs to R, but then CC is not belongs to R2. So this is not reflexive. So for symmetric we have to check AB belongs to R, BA belongs to R. This condition satisfy. So we can say this is an symmetric relation. And for transitivity we are checking that A belongs to R, AB belongs to R, then AB must be belongs to R. If I am moving to this pair, AB belongs to R, BA belongs to R, then AA must be there. So this is an transitive relation. So this relation is symmetric and transitive, but this is not a reflexive relation just because CC is not there. Okay. Now moving to the third set of relation, that is this one, and we are checking that if this relation is reflexive, symmetric or transitive. So for start with the reflexive one, AA, BB and CC, all three are there, so we can say that this is a reflexive relation. And whatever symmetric, if AB here, BA is also here, but when we move to the another set, CB is there and BC is not there. So symmetric condition is not satisfying, so we can say that this relation is not symmetric. And now I have to check about the transitivity. If AB belongs to R, AB belongs to R, then I am searching for the pair BC. BC is not here, BA is here, and if I am moving here, it's AA. AA is also there. So this is an transitive relation. Okay, CB is here. Okay, one moment. The next pair is CB is here. So this for me is A and it is B, and BA is here, B, C. So AC must be belongs to R. That means CA must be belongs to R, but there is no pair indicating CA. So this relation is not transitive. You have to check all the pairs that if these two conditions satisfy, AB belongs to R, BC belongs to R, then AC must be belongs to R. But in my case, CB belongs to R, BA belongs to R, but CA does not belongs to R. So this is not an transitive relation. Okay. Moving to the next one, the fourth set of relation, AB is here, BA is here and BC is here. Okay. So for saying this, we can simply say that this is not a reflexive relation, because in reflexive relation AA, BB and CC must be there. So I can say that this is not a reflexive relation. I am just finding second condition, that is symmetric relation or not. AB is here and BA is here. So for these two pairs, symmetric condition is satisfied. But then if BC is there, CB must be there. So CB is not here. So we can say that this is not a symmetric relation also. But transitivity, AB is here, BC is here, but AC is not here. So it is not a transitive relation. So this set of relation is neither reflexive nor symmetric nor transitive. Okay. And moving to the next set, it is AA, BB and CC. So by seeing this, we can simply say that this is a reflexive relation. Now we are very familiar with the reflexive one. And for the symmetric one, I am just saying that if AB is here, BA must be there. So it is satisfying the condition. So it is also symmetric and it is also transitive. Okay, now why I say that this is a transitive relation, because I told you that if these two conditions satisfy, then you are going to check the third one. If any one of these conditions are not satisfying, that you are not going to check the third condition. That means in this I am not having BC. For example, I am only having this pair AA and BB. I am not having any pair related to AB and BC. So we are not going to check the third one. We are simply declaring it a transitive relation. Okay, and the last one is BB. If BB is there but AB is not here, AA is not here, CC is not here, so it is not a reflexive relation, because the condition of reflexive relation must be followed by all the element of the set. So it is not a reflexive relation. And if I talk about symmetric one, BB, and the opposite of this is also BB is also here, so it is a symmetric relation. And transitivity, it is also a transitive relation as described in the last relation. If these two conditions are not satisfying, we are not going to check the third one, we are simply declaring it a transitive relation. Okay, and the last one says AB and BC. Okay, by saying this we can simply that it is not a reflexive relation, because no element is relating to itself, so it is not a reflexive one. And what about symmetric? AB is here but BA is not here, so it is not a symmetric one. AB is here, BC is here, but then AC is not here, so we can say that it is not a transitive relation. So this relation again is not reflexive, not symmetric, and not transitive. So we are now familiar with the type of relation. With the help of definitions we can find which relation is reflexive, symmetric, and transitive. Then we are familiar with the type of relation, and now what we are doing, we are moving to the operations upon the relation. That means if I am telling you to find the complement of a relation, set, then how can I find? Okay, these two words are very familiar to us. Very firstly, we have to rewind the definition of relation. What is the definition of relation? I have already told you that it is association between two sets, and I have already told you that relation set is a subset of the Cartesian product of two sets, that R is a subset or equal to A cross B. We have already mentioned it. And what is the complement? We have already studied this word in the set chapter. We have find the complement of a particular set, and complement of a particular set is the universal set minus the element of the set. If I have to find the complement of set A, what will I do? Universal set minus set A. This will give me the complement of the set. That means the elements which are not present in my set are in my complemented set. So same definition with the relation. For relation, what is universal set? Universal set must be the Cartesian product set. If I am describing a relation on a single set, what will be my universal set? It will be A cross A, and I am subtracting the set of relation R from the universal set. So what is the complement of a relation R? It is given by A cross A minus R. It will give me the complemented relation set. Okay, this is a universal set for relation, and this is my own set of relation. I am subtracting this, I am getting the complement of the relation. Okay, let's take an example. If a set A is 1, 2, 3 and a relation R is given such that A is less than B for all A belongs to capital A. So what will be the set of relation for me? 1, 1, 2, 2, 3, 3, 1, 2, 1, 3 and 2, 3. This will be my set of relation. according to this condition I have derived this one. And what will be A cross A? I have already told you how to find the Cartesian product. Cartesian product of A with the same set. So what will be the set? 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. Okay, so this will be my set of Cartesian product of set A with itself. Okay, so what I am trying to find the complement of relation R, that will be given by this set minus this set. So all the elements which are in this set but not present in this set. So what I am going to do, I am just subtracting these elements from this set. So 1 1 I am going to subtract it, removing it. 2 2 I am going to removing it. Then 3 3 I am going to removing it. 1 2 removed. 1 3 removed. Then 2 3 it is also removed. So these are the remaining element. So these are the element of A cross A minus R. So when I subtract the relationship set R from the Cartesian product, I will get this one. If I arrange it in the proper manner, it will give me 3 2, 2 1 and 3 1. By seeing this set, you can simply derive that these are the elements which are not satisfying the condition of the relation. That means the condition of the relation was A is less than B, but these all are not satisfying the condition. So that will not belongs to R, and that will belong to the complement of the set, that means R bar. We can represent the complemented set with the bar on the set and small c on the set and dash on the set. So these three are the presentation for complemented set. We have already discussed in the set chapter, I am repeating it, and here you can find the complement of a relation. Okay, and the last operation on the relationship set was, if I have to find the inverse of a relation. So these two words are totally different, inverse and complement. If I have to find the inverse of a relation, how will I find inverse of the relation? In this we are only inverse the order of the element. That means if I have a relation 1 2, 1 3, 2 3, 3 4 and 4 1. This is a random set of relation. You can take any example, and if you have to find the inverse of a relation, so inverse of R will be equal to, we inverse the order of element in the relation. That means if 1 2 is there, I am just opposing it 2 1, 1 3 is there, I am doing it 3 1, 3 2, 4 3 and 1 4. If I am just changing the order of the element in the relationship set, I will get the set of inverse of the relation. So these two operations can be performed on the relation. You can find the complement of the relation, and you can also find the inverse of the relation. Some other operation can be performed on the relation set. For example, you can find the union of two relations, you can find the intersection of two relations, and difference between two relations, R1 minus R2, R2 minus R1, but they are all same as the set, because what is relation, it is also represent with a set. So as I have discussed the union operation in a set, same way you can present, you can find the union of two relation. So just try to do it yourself firstly, and if you have any problem in that, you can comment in my video lecture. I will explain you in my next lecture. Like my video, and please like, comment and share my video, and don't forget to subscribe our channel. Thank you for watching.